Now we want to determine the tension in each cable by drawing a force diagram for the system. So first, here we have this mass. There's a tension force acting up, and there's its weight force acting downwards. Now, this object is standing still. That means the forces are balanced. Not moving means balanced. So that means the tension points up, the gravity force points down, and the effect is zero. They're balanced. So we use the free body diagram to set up the equation just like we did in class. Now that means the tension force minus the 10 Newton gravity force equals 0. Notice this is 10 newtons, not kilograms. Finally, when we solve, we're going to get that the tension force equals 10 newtons. Similarly here, we've got two tensions. So I've got Ft and a similar Ft, and I have the weight pointing down. Now we know these are balanced, so we have Ft plus Ft, these are supposed to be two cables, minus Fg equals 0. Now let's be careful. We have here Ft plus Ft, that's 2Ft, minus, for Fg, I'll put in 10. That equals 0. We'll add 10 to both sides. So we end up getting that 2Ft equals 10. We'll divide both sides by 2. So the tension in each cable is 5 newtons. Perfect. Now for number 4. We are pushing this object. It doesn't move. We have a force of gravity. It says draw the free body diagram of the block. So let's be clear. We are pushing with this force F here. We know that the box is on the ground, so there's a normal force. There's a weight. And since the box is not moving, we have to conclude that there's a friction force balancing the pushing force. It says calculate the normal force on the box. So we have Fn minus Fg, and that balances. It equals 0. We know that. It's balanced vertically because it doesn't accelerate in the vertical direction. It's completely motionless in the vertical direction. So we have Fn minus, now are we given a weight for the box? We are, 300 newtons, and that equals 0. So we're going to get that the normal force is 300 newtons. Great. Now, it says calculate the friction force in the box. So we have the pushing force, minus the friction force. That also balances because the box is not moving. We're pushing with a force of 15 newtons. There's a friction force that balances it. That tells us that the friction force also ends up being 15 newtons. So that is page 2. We'll move on to page 3 in the next video.